A Chinese AI model just closed the gap on ChatGPT and Claude, and the world's biggest labs might have to rethink their lead. Welcome back to Midnight Signal AI. It's July 4th, 2026.
And that's just the start. Anthropic's new Claude faces a China ban, Fable 5 returns after U.S. export restrictions, and Microsoft launches an Arabic GPT 4.1 model. Plus, new research is pushing agentic AI in wild new directions. Let's dive in.
Let's start with that Chinese breakthrough, because if you thought the AI race was locked up by the US and UK labs, think again.
This is a big moment. For years, people assumed the US and UK labs would dominate, but we're seeing China's models not just catching up, they're now being mentioned in the same breath as Claude and ChatGPT. That puts huge pressure on Western labs to keep innovating, and it raises all the old questions about global standards, data access, and even export controls. If the gap keeps closing, we could see a very different balance of power in AI within just a year or two.
And that competitive landscape is already turning tense. Case in point, Alibaba just banned Anthropic's Claude code over alleged security risks. Let's dig in.
This is a classic example of how geopolitics and security concerns are shaping not just model access, but the entire developer experience. Alibaba's decision isn't just about one tool. It could accelerate the rise of Chinese-built coding models and make it much harder for U.S. labs to compete in China. Expect more of these walled garden moves on both sides as the stakes rise.
Now, over to Anthropic, who, despite those headwinds, just launched Claude Sonnet 5 as their latest agentic model. This one's all about making AI act more autonomously, and it's already drawing a lot of comparisons to GPT 4.1.
Agentic AI is the next battleground. Sonnet 5 isn't just smarter, it's designed to handle more steps on its own. Think less hand-holding, more just-do-it workflows. If it delivers, this could change how teams automate internal processes. But it also ups the stakes on oversight and safety. The pricing move is interesting too. Anthropic's clearly going after volume and enterprise budgets.
And that's not the only Anthropic headline. Their Fable 5 model, which was briefly pulled due to US export controls, is now back in subscriptions, though not without controversy. Let's break down what's changed.
Fable 5's return shows just how volatile access to top models has become. Anthropic had to tweak both policy and underlying safeguards to get the green light. For users, it's a relief, but it's also a warning. Advanced AI access is now tightly coupled to geopolitics and export law. The real test will be whether these new cyber protections hold up against hackers and jailbreakers.
Switching gears, Microsoft and Inception 42 just launched Siraj, a new Arabic language AI model based on GPT 4.1. This is a huge step for language diversity in LLMs, and it could transform how Arabic speakers access advanced AI.
This is a long overdue move. Arabic speakers have been underserved by frontier LLMs, and Siraj could fill a massive gap, not just in consumer chatbots, but in governments, education, and finance. There's a lot riding on how well it handles dialect diversity and local context, but the demand is there. Watch for more regional language models soon, especially as cloud infrastructure expands in the Middle East.
Meanwhile, Meta is gearing up to launch a new version of Musespark, their AI model with improved coding capabilities. This comes as competition in code generation heats up, especially with the likes of Claude Code and Cursor making waves.
Meta's timing is interesting. There's a real arms race in AI coding assistance right now. If Musespark can meaningfully improve coding quality or integrate tightly with Meta's platforms, it could grab serious share, especially among new devs or teams in Meta's ecosystem. But the bar is high, and getting developers to switch tools is always tough.
On the research front, let's talk about Wiola, a new small language model architecture that claims zero overlap with GPT, Llama, or Mistral. Wiola is introducing 5 novel components, including a wild 3D positional encoding system and adaptive token merging. It's been released in 4 sizes and is fully Hugging Face compatible.
I love seeing this kind of pure innovation. Nearly every SLM in the wild is some spin on GPT or Llama. Wiola's from-scratch approach could shake up both academic and applied SLM work, especially if those adaptive token tricks prove efficient. It's early, but if the performance holds up, this could push other teams to rethink the fundamentals.
Agentic AI research is also booming. One standout, Agent 4CS, a multi-agent code summarization system designed for massive, messy code bases. It uses 3 specialized agents, one for summarizing, another for keyword extraction, and a third for QA. And it's showing up to 38% gains in keyword coverage over structured prompting baselines.
Multi-agent is quickly moving from theory to practice. For big companies with sprawling legacy code, tools like Agent 4CS could be a lifesaver. Think faster onboarding, cleaner docs, and fewer nasty surprises when old engineers leave. If it generalizes, this could become the new normal for code intelligence at scale.
Speaking of agentic pipelines, another new paper, EO Agents, applies a 3-agent LLM pipeline to scientific hypothesis generation grounded in actual NASA Earth observation data. It's produced 160 new, plausible research hypotheses across climate and atmospheric science, and it shows that AI can now generate scientifically coherent, testable ideas from real structured data.
This is what gets researchers excited. LLMs not just summarizing, but generating actual new science ideas, grounded in real data. The plausibility ratings are impressive, but the real value will come from seeing if any of these hypotheses lead to published breakthroughs or new discoveries. Expect more AI as research partner stories soon.
And on the alignment front, a new paper proposes a robust, list-wise preference optimization method for LLMs, basically a safer, more reliable way to rank and align model outputs, even when label data is noisy or inconsistent. It's a technical step, but it could be crucial for the next generation of reward model training.
This is insider baseball for most users, but it's a big deal for anyone training or fine-tuning models. Alignment is only as good as the feedback you give, and real-world data is always noisy. Better handling of those ambiguities should mean safer, more consistent LLM behavior and fewer surprises in production.
Quick follow-up on a story we last covered on July 3rd. The lawsuit alleging ChatGPT exacerbated a bipolar man's delusions has escalated, with new details about the model's responses now part of the court filings. The outcome could set a precedent for how labs handle mental health safeguards.
That case is being watched closely by both policymakers and AI ethics teams. Depending on the verdict, we could see labs ramp up mental health protections or face stricter liability rules.
And one last commercial launch. Z.ai just released ZCode, a new AI coding assistant aiming to challenge Cursor, Claude Code, and Copilot. The code gen wars are officially in full swing.
It's a developer's market right now. Every week brings another code gen tool with a new twist. ZCode will have to prove it's got something unique, but the competition should drive better features and lower prices for everyone.
That's it for today's main news. Stay with us. More robotics, medical, and hardware roundups are coming up next. Before we close things out, a few quick signals from beyond today's headlines. Now, let's start in robotics. This one is about a very human problem, a robot trying to keep up with a group that does not stay neatly arranged. The paper looks at adaptive companionship for group-following robots, where the challenge is not just navigation, but social positioning. A group might bunch up, fan out, or split for a moment, and the robot has to decide where it belongs without feeling invasive or clumsy. It uses vision language models to reason about those changing formations, so the machine can infer companion positions and maintain social distance with more context than a simple tracking algorithm. That's a big deal for service robots, guides, and anything meant to move through public spaces without becoming the awkward fifth wheel.
So the robot is basically learning manners, not just movement.
Exactly. And that's where social robotics starts to feel less like a demo and more like a real presence. The hard part is not just following people, it's understanding the social geometry of the moment.
Which is probably the difference between a helpful companion and a very expensive obstacle.
Pretty much. If robots are going to share space with us, they have to read the room, not just the map.
Which, once they can do that, the whole idea of companionship gets a lot more interesting. It's not just about path planning anymore, it's about timing, distance, and whether the machine can adapt when the humans change their mind mid-walk.
Over in healthcare AI, the focus is shifting from easy multiple-choice wins to harder, more realistic reasoning. This paper presents a rubric-based controlled comparison of frontier language models on clinician-authored cases, and the key idea is simple. If the benchmark is too shallow, you do not learn much about actual medical judgment. So instead of a pile of broad questions, the authors built 5 deliberately difficult scenarios across anesthesia, internal medicine, emergency medicine, and obstetrics. Each one is paired with a detailed scoring rubric, many atomic criteria carefully weighted, so the model gets judged on whether its reasoning actually hangs together.
That sounds much closer to how medicine works, where partial credit matters and one wrong assumption can ripple outward.
Exactly. In medicine, the point is not to sound confident. It's to notice uncertainty, prioritize correctly, and avoid dangerous shortcuts. This kind of evaluation is valuable because it can separate genuine reasoning from fluent guesswork.
And it probably gives researchers a better map of where these systems are helpful and where they still need a human in the loop.
That is the real takeaway. Better benchmarks don't just grade models, they show us what safe deployment would actually require.
And that matters because the next wave of medical tools is not going to be judged by whether they can answer a trivia-style question. It'll be judged by whether they can support real decisions, under pressure, without losing the plot.
On the hardware side, there's a very practical problem hiding underneath the glossy AI conversation. Getting kernels to run fast on NPUs is hard. The Hawk paper is about hardware-aware knowledge for high-performance NPU kernel generation, and the reason that matters is simple. These accelerators are picky. Memory hierarchies, layout choices, and low-level constraints can make or break performance. A generic model can produce code that looks reasonable and still fail badly when it hits the real device. So the point here is to give the system more hardware-specific grounding so it can generate kernels that actually respect the architecture instead of fighting it.
That sounds like a huge deal for anyone building infrastructure, because the last mile is always where the pain lives.
Exactly. We talk a lot about model quality, but in practice, the bottleneck is often the code that makes the model usable at scale. If AI can help automate kernel generation, that's not just a convenience. It can unlock a lot of performance work that is currently manual and specialized.
And it's a reminder that hardware is still where abstraction meets physics.
Right. No matter how smart the model is, the chip still gets the final vote. And to end on a lighter note, there's something pleasantly nerdy about a benchmark where the tests have to keep up with the code. Test Evo Bench is all about test and code co-evolution. Basically, if the software changes, the test suite should reflect that change instead of pretending nothing happened.
So it's like a benchmark with a memory.
Exactly. And the fun part is that this makes evaluation more honest. It's not enough for a test generation agent to spit out something that looks plausible. The test has to be executable, relevant, and actually tied to the code update.
Which is refreshingly close to real software work, where the boring details are usually the important ones.
That's the joke, yes. The most human-sounding part of the story is also the most practical. Good tests don't just exist, they evolve. And if an AI can keep that relationship intact, that's a nice little win for everybody who has ever stared at a broken build at midnight.
Across today's stories, a few things stand out. First, the Chinese AI surge is real, and it's forcing a rethink of tech leadership and regulatory strategy. Second, the Agentic wave, from Sonnet 5 to Agent 4Cs and EO agents, is bringing new capabilities and risks, especially as autonomy and access become policy flashpoints. And third, the code generation arms race shows no sign of slowing down, with every major lab and startup pushing for a slice of developer mindshare. As these trends converge, expect the lines between research, enterprise, and geopolitics to blur even further. We'll be watching it all.
We'll leave it there for now. Thanks for listening to Midnight Signal AI. Until next time, keep building, keep questioning.